Welcome to the 2023 Winter and Spring Capstone on AnyMile, improve warehouse efficiency and flexibility through drone-based autonomous warehouse logistics in collaboration with Mitsubishi-Electric. My name is Eric, and I'm the team lead, and I'm responsible for project management, hardware setup, and pose estimation.
My name is TU. I was responsible for designing the gripper and programming the camera.
My name is Zhang Wang. I'm a group member, and my job is to design the gripper carriage and the movement mechanism.
Hi, I'm Li Hongbai. In this project, I trained the object detection model and code the box selection algorithms.
Our project came out of a Mitsubishi project that wanted to deliver small volumes of items by drone to areas that were difficult to reach by human. The drone delivery can not only improve the efficiency of delivery, but also greatly reduce the cost of labor. In addition, the small size of drones can adapt to more complex environmentals. At this stage, our task is to set up the gripper movement mechanism of the drone on a set of 3D printers, which can not only identify and locate the packages from the shelves with computer vision.
Next is the system overview. Our system consists of a 4 degrees of freedom robot with 3 translations and rotation about the vertical axis, in addition to the gripper actuator. We also have an RGB and depth camera that we can use to process images into an area center with an angle for all the boxes, so that we can move the gripper to each box and then grab them.
The program starts with getting the JPEG image from the camera RealSense, then segmented by YOLO V8, which are all programmed on the JSON Auto. The G-code is then exported to Clipper in order to send the command to the stepper motor, which eventually puts the gripper into motion.
The RGB image and the depth image from the camera will be matched together after object segmentation to obtain the geometries of the boxes like their coordinates and angles for the gripper to work. If all the boxes are relocated or no boxes are detected in the site, a cycle is complete.
This is what our 3D printed gripper and carriage assemblies look like. Overall, most parts fit very well and have high printing quality. Figure on the right-hand side is an exploded view of our jug-based gripper design.
Speaking of the object detection model, we started with YOLO version 8 by calling the Ultralytics API. 20% of the dataset is self-made boxes images where we apply tons of augmentation like rotation, shearing, and shadowing. Up to this point, we get an average precision of 87% for medium-sized objects.
To estimate the pose, we fit a rectangle to the segmentation mask of each box. Doing this, we get the area center, width, height, and angle in the image coordinates. This can then be converted to camera coordinates so that we can move the gripper to the area center and rotate, as illustrated on the right. Here is a video of our prototype in action. Prototype starts by finding the boxes and estimating the poses, and after selecting a box, it goes to grab it, as shown now. After the box is grabbed, it is simply taken up and into one of the corners before it is dropped, emulating the fact that this is a box with a destination, before returning to the 0 position ready to pick the next box. Here you can see us start to build our prototype, which is based on the Voron 2.4 3D printer. By repurposing this 3D printer, we saved a significant amount of time as we did not have to design our robot from scratch. By repurposing a 3D printer, we also got an additional benefit. Since we now were in possession of a fully functioning 3D printer, we could manufacture the gripper and gripper carriage ourselves. Here you can see the gripper carriage and gripper with the attached RealSense depth camera. After everything was assembled and the hot end of the 3D printer replaced with the gripper, we started testing our prototype. Through testing, we finalized our code by, for example, adding the offset between the gripper and camera to accurately grab the boxes. Finally, after several iterations of testing and tuning, we got a prototype that was fully functional.